Hello, my name is Deakyne, and I'll be going over my abstract titled Development of Anaglyph 3D Functionality for Cost-Effective Virtual Reality Anatomical Education Tool. So for a bit of background here, virtual reality is a rapidly maturing field, and it's seeing wide use in education and industry, and it's been shown to increase educational outcomes when used because of the immersive environment it creates. We're seeing wide use in medical school and physician training because it can depict these 3D anatomical models in an immersive environment. So you have a cardiac blood volume here model. Instead of just looking at it in a 2D image here, we can put it in virtual reality. It's fully rendered in 3D. We retain all the spatial information, and it's just a better way to study in the detailed anatomy and to learn it. Unfortunately, when you go up to more than one person, it can get really expensive for large audiences because everyone either needs their own headset and computer, which puts the price point in the thousands, or one person is wearing the headset and everyone's watching what they're seeing just through a 2D screen, which now you're losing all that rich spatial 3D information. And so our solution to create a cost-effective tool for large-scale anatomical education using VR is to use Anaglyph functionality. So we've created an Anaglyph filter that can be used within our VR platform that can now render the output image, whatever the virtual reality user is seeing, in this Anaglyph filter. And so Anaglyph just uses the traditional red-blue 3D glasses, and what that does is it offers a 3D perspective on a traditional 2D screen. And these glasses can be purchased for extremely cheap, a couple hundred of them for a few dollars. And so the way that this works is we needed to do a little trickery because Unity only lets us output one camera view to an external display, and that's usually the VR's user just put into a 2D perspective. And so in order to kind of circumnavigate this, what we had to do is we had to create two Anaglyph cameras, one for the right eye, one for the left eye, that are children of the VR user camera. So wherever the VR user is looking, that's exactly where our cameras are looking. And then we take these two camera views and we put them onto the screen, which you can see in this image here in the front, and they get rendered on top of each other. And the right eye gets rendered with the red Anaglyph filter, and the left eye gets rendered with the blue Anaglyph filter. And this is done through a custom script that applies a 3D Anaglyph shader. So it just takes what are two rendered images and applies this red-blue tint to give us an Anaglyph output. And now this screen that's rendered that you can see in the front is what's going to be sent to the output of the 2D screen for everyone to see. And so now we have a VR user's view that's completely unchanged, so that we can't apply the VR or the Anaglyph filter directly to the VR user, or they'd be seeing red and blue. And so our Anaglyph filters and cameras take care of that, so the VR user's view is unchanged, and displayed on the 2D screen is still rendered in this full Anaglyph 3D. So everyone looking at the screen now gets a 3D perspective of what the VR user is seeing, instead of just your 2D kind of warped perspective that loses a lot of the, again, the rich spatial information. And so this allows for large audiences to view the VR output in a 3D perspective, again, retaining all the rich spatial information and the detail of the anatomy. So you can see here on the bottom of the screen, we have two images. One showing a bifurcation stenting technique rendered in Anaglyph output. On the right, we see an evolute valve, the leaflets coming out at you rendered in Anaglyph. And on the right of this slide, we see an instructor at the University of Minnesota in the physiology course driving through an anatomical model using the VR headset at the front of the class, while the rest of the class is viewing the screen that's outputting in this Anaglyph filter with the red-blue glasses, so that you can still see the 3D, a 3D perspective of what the VR user is seeing. And so effectively here we've created a simple and cost-effective solution for using VR for large-scale anatomical education. Thank you.